Hi, my name is Ayan Alamayo,
And I'm Subha.
and this is our 6205 final project. For our final project, we decided to create a QR code scanner, as you can see by the QR code on the screen. And our physical setup consists of this camera module, the FPGA, and through HDMI, we display a 480 by 480 screen of the camera's output.
Yeah, so our QR code scanner can actually decode a QR code that takes almost 240 by 240 pixels of the original 480 by 480 HDMI outputs, and it can actually decode the QR code in almost 0.02 seconds. So now we're going to create a custom QR code to actually show the process of decoding. And for this, we're going to use this website, which actually allows us to create custom QR codes. So now we're going to specify the QR code version to be version 1, which is what our project supports. And this is where we're going to encode in the QR code. So let's say our names and the class number, 6205.
So our QR code scanner works by first taking a photo. The main goal is to just try to get it as unrotated and straight as possible. So let's try, and that should be good.
Yeah, so now we're going to show you the actual process of decoding this QR code that we created, as we have seen. And so our first stage is to be actually denosing this image, because as I'm not sure if you've seen it, but like someone in the room would see it clearly, there's a little bit of artifacts, like small black dots artifacts in the image and small white dots in the black region of the QR code. So what we do is we apply a denosing kernel on the QR code, and it actually cleans some of these artifacts.
Next up in the steps for decoding is to actually detect these alignment patterns. So if you can look at it, you can actually see that the squares overlaid onto these alignment patterns are perfectly on top, but you can also see that there's this random square in this corner as well.
Our next step is to actually find where are these finder patterns, and we should actually get rid of this extra artifact that we have. And in order to do this, we actually divide the image into nine zones. Each zone contains a potential finder patterns, and then we actually run through each zone separately and look at the finder patterns. If the majority of the pixels within this potential finder patterns are black, as we have seen, like it's perfectly aligned with the finder pattern here, then that means that this is an actual finder pattern that we care about. After actually looking through all these different zones, we can actually see now the 3 dots, which are the centers of the QR codes. It might be not clear on the camera, but like a person here in the room would actually see it very clear, which is we have like 3 dots, like a red dot here and a green dot in here and a blue dot in here.
The next step actually in our algorithm is to downsample the QR code. So the way we downsample is we go from each alignment pattern and we just try to find out what the module values in that certain area were. And yeah, we compile all those together and we create a final QR code and final downsample QR code, and then most importantly, we unmask this QR code. So that is what this is. This is the unmasked QR code. All QR codes have a mask applied to them to remove weird shapes and weird forms of the data that might make our QR code scanner think it's a finder pattern when it's looking at it. And once we unmask it, we're actually able to read it.
Once we unmask the QR code, we can actually start reading the data. So the data has a specific structure. For example, first here on the bottom right, we have 4 bits specifying the type of data that we have. It's either bytes, like pure bytes, or numeric or alphanumeric or kanji data sometimes. And then it has 8 bits, like a byte, specifying the length of the data that we have throughout the QR code, like the number of bytes we have. Then we actually start reading the bytes in a specific order as shown here on the screen. So this is our first byte, second, third, fourth, and so on.
And so now all that's left is to actually see what our QR code has read. So we communicate with our QR code through Manta, and right now it's telling us that the data type was 4, which means it was a bytes encoding, that the data length was 17, and that the decoded values are our names. So it worked out. Our QR code scanner successfully decoded.
That's our project.
And that's our project.